Alrighty, welcome back. I've got a midterm tonight on Go programming, and so I should probably practice that as well as the concepts of concurrency that we have learned. Oh, and I am streaming because if I'm not streaming, I'm gonna be fucking looking at YouTube shorts. So let's get to her. Where we left off last time, we had just finished up copying all the code from this. We'll go to the 45-minute 15-minute sort of schedule because my midterm is at 7, so I can just keep going. I'll probably go until like 2, so maybe do this for a good 3 hours. Take the dog out and come back. So where we were on lab 3, part 2. And we were reading in from pointcloud.xyz, and this gives us all the points, and we're doing a thingamabob where essentially we're calling distance 3D on all these different points, and we're trying to find the maximum distance between two pairs of points in a thingamabob. So how are we going to set this up in a concurrent fashion? Okay. So it's asking to use data parallelism to solve this problem. The data parallelism strategy is the fan out, fan back in that we were doing last time. So yeah, data parallelism, the data set is split into subsets processed by different threads. It's the one at the end here. Yeah, fan out in a pipeline. This is parallel array processing. Yeah, data parallelization. Set of data is split into subsets that are processed by concurrent threads. The same operation is applied to all data. There's usually a sweet spot between the size of data splits and the number of processing threads. When too many threads are involved, the forking overhead tends to dominate. This is often the easiest strategy for parallelization, synchronization, fork join. So, easy synchronization with weight groups. We have a weight group, we have an array, we have some sort of array that's going to take in all these inputs, I guess. Add to number of threads to be synchronized to slicing array. So basically we slice up this array into two parts, two concurrent threads, and then we wait for each of these to be done. And the output is written from the input to the output. Boom, shakalaka, as simple as that. Fan out into a pipeline. All stages are read from the same input channel and also write to the same output channel. So that's where you have all these filters. Fan out stage and building a complete pipeline, and then the fan out in a pipeline, fan in. So I need to come up with the fan out part first. So we need to figure out how many times we want to fan out. So what's the strategy going to be here? Let's open up Paint to visualize this. So let's first ask how we are currently processing this. So we have points, which is an array of point 3D objects. And it's basically for every object in point, we create a new index, and it's going to be the index of the point plus 1. And then we increment this so long as it's less than the length of points. And then we find the distance between P here and points that we read from the index. So I don't actually think we're doing every single pair. So We might be. We might be. Okay. Because pairs are replicated in each instance. Like what I'm thinking of is if where the fuck is the box here? There we go. Shapes. Like say we have a set with 1, 2, 3, and we want to come up with all pairs of that. We have 1, 2. We then have the strategy is just go through and find all the pairs between it. So we have 1, 2, 1, 3, and then we have 2, 1, and then we've got 2, 3, and then we've got 3, 1, and 3, 2. These are all possible pairs where ordering is important, but ordering is not important when we're looking at the distance between 2 points. So 1, 3, and 3, 1 are identical to each other. We can just get rid of 3, 1. Boom. 2, 3, and 3, 2 are identical. We can just get rid of it. Boom. And 1, 2, and 2, 1 is identical. Boom. So there's only 3 unique combinations where there's only 3 unique combinations where ordering is unimportant, or when ordering is unimportant. So that's probably what's happening with the points. We probably have some point objects here. So we have P1, P1, P2. I'm just going to do it under case because it's going to fuck me up. P1, P2, P3, P4. So if we were to go through all pairs of that, that would be P1, P2, P1, P3. Why did I do 4? Jesus Christ. P1, P3, P1, P4. Oh, I'm also forgetting that there's the pair P1, P1, but that's obviously not included. P2, P1. Yeah, so this algorithm does account for all pairs, because every time we pair 2 with something before it, it's already a pair that we've got. So we don't have to go back. We can just keep incrementing, because that's the one thing I was seeing here. We only move forward, right? We don't move backwards. So we don't get any of those backwards pairs, like 2 pairing with an element before it, P1. But we don't have to worry about that because that pair has already been accounted for. We only need to move in the forward direction. Okay. All right. Okay, yeah, so this should give us every single unique pair of points going through here. That's nifty. Don't save. So now what I need to do is create a fan-out strategy and call distance for all of these points. Typically it says there's a sweet spot, so we should... Okay, hold on. I need to pee, so I'll be back real quick. Then we can get back to this. Salut. Okay. So let's review the code for fanning out. It's easy synchronization with weight groups. For fanning out, we have an output in stream. That takes the output of this, I guess. So we have a weight group for the fan out. Yep. I don't have any water. I'll be back with water. Christ almighty. Okay. Creates all filters of the fan out. Alright, so you create all the filters of the fan out. So this is for each fan out number that you've defined. Where is fan out? Oh, okay, this is a function for fan out. Okay. You then create a thread. You defer the done call to the wait group. You defer the print line as a little marker there. And then for each thing that you get from the input stream, if you're not getting anything from the input stream, or if it's stream I, what do you mean filter I? Oh, if not filter I. Which one's filter? Filter is the function that you're getting. Where's the filter function here? Yeah, filter is a function that's being passed through the parameter here. That should just be any function that you get, eh? I guess so long as you don't get an error from filter, you output it, and then you do a select case. What's I in this case? Where am I defining I here? I comes from the input stream. Okie dokie. Okay. So yeah, I is whatever we read in from the input stream. We then feed I to filter. And if filter says it's all good, then it passes through. We continue. Or if it's not filter, or a filter, I'm guessing filter is supposed to be a Boolean. It is supposed to be a Boolean function. Okay, yeah. So if it's true, then we do not. Wait, no. Okay, yeah. So if Boolean returns false, then we skip over this range. We don't go through with this thingamabob. Else we have select stop, which tells us our threads to stop, and otherwise we throw I to the output int stream. Okay. So this helps significantly. What we could do, what I was initially thinking is, oh, we're going to have to call, what is it now? We are going to have to call a go thread on each time we calculate distance from the distance function here. Like basically for each different pair, what we could do for each pair, okay, we create a channel. Each time we have a pair, we create a thread that processes that thread, right? I put this to 3. That's 5 pixels. I don't like 4. Yeah, that works good enough. Yeah, we put a thread there, there, and there. What we could do instead is we could have each time we call the distance function, it gets sent to a single channel. And then that channel gets fed to the fan out function. And the fan out function handles sending that to a designated number of fan out threads. So let's say that instead of 1 for every pair, which let's say there's 20 pairs or something like that. Say we only want about 5 parallel threads running at a time. That's 5 right there. We send 5 along with the fan out function, as well as the channel that we're going to be sending the information to for the distance function. And we pass the distance function as a function for the fan out function. So basically it goes, all right, do all this shit. Calculate it and only send it to about 5 threads. Boom, 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 boom. And so this way we can control how many parallel threads we create. We send the 2 pairs and then we send, or we don't send the 2 pairs, we send the channel. And then we send the function to do the work, which is distance. Encoding overloaded. Consider turning down video settings or using a faster encoding preset. That's streaming jargon that I don't know how to understand or react to, so we're going to ignore it. So, okay, we'll try and figure out a function here for this shit. We'll create a func fan out. And it's going to take a weight group. I wish I could type, man. Holy shit. Sync.weight group. It's going to take a stop channel. It's going to take an input stream, which is going to be a chan of... Should I create a pair of... What is it now? A pair of 3D points? Or should it just be an input stream of 3D? Of a single 3D point? The thing I'm worried about here is to make sure that we're actually doing each point, the points should be sent in order. But the thing I'm worried about is that the threads are going to read from each point. So let's say I have a queue here of P1, P2, P3, P4, P5. So what I'm worried about here is I need to figure out the pair of P1 and P2. And so P1 gets sent into the input channel here, and then it gets read to channel 1, like parallel channel 1. But then I need the second one to also be sent to parallel channel 1 to do the calculation properly, right? To calculate that pair. But what happens instead is that P2 gets sent to maybe the second thread here instead of the first one. And so I'm not actually calculating the distance between P1 and P2. And then say P3 gets sent to the first channel instead of the second channel or whatever. And so I can't have any control over which pairs are being processed, and I can't confirm that I've checked every single pair. That's the one thing I'm worried about here. So how do I ensure that? I could ensure that by sending each pair through. So this successfully generates each unique pair. And it's going to be P and PTS, right? So I can't call the distance function because I want to call it as a thread, right? All that shit needs to be sent to the function fanout. And so that information needs to come from the input stream. And so if I send it one at a time, I need to make sure that it's almost like a buffered. I'm wondering if a buffered input stream would work best for that, or if that's would be better handled by creating a struct that holds a point pair. So let's go back to perhaps buffered. This is, imperative programming with Go, concurrent programming with... what is imperative programming exactly? Programming. Process state. I think imperative programming is just regular programming. Yeah. Need to close the... so zoom out a bit. Go programming language. Go is developed by these people. Go features, Go combine. Fast compilation, fast execution, simplicity, Go pattern, procedural language, not object-oriented. What's not in Go? Function overloading, implicit type converges, no classes, no exceptions, no assertions, no parameterized type, Go program structure, small Go program, there we go, types, variables, multiple return values. I actually do like that a lot about Go. Idiomatic Go. Error handle. I also really like Go as error handling. Testing the return value. Function as a parameter. I like that as well. I really like how easy it is to send a function through a function parameter in Go. Lambda functions. They're also pretty easy, but they're kind of similar to Java, so I can't say like I like them that much. Structured pointer, Go arrays, Go slices, append and slice, generic types, other generic types are so fucking complicated in my mind, honestly. I do not understand them all that well. Read from the keyboard. Nice. Read and write to a file. Deferred execution. No exceptions in Go, triggering a panic. Go methods and receivers, method definition, method call, embedded types, interfaces, implementing an interface polymorphism, an empty interface. What the fuck's even going to be on our midterm exactly? Okay. So it seems that buffered channels are going to be in this lecture. Go routines, calling Go routines is a function, execution. Concurrency is non-deterministic, which is unfortunate. Communicating between Go routines. Go channels, declaring a channel, read write to a channel, communication between Go routines, closing a channel. Range, implicity, check channel status, communication between Go routines, handling multiple channels. Using a channel. I need to just review these stuff in totally. Semaphore. concurrency mechanism used to control the access to a resource or to a critical portion of code. Go semaphores can be implemented using buffered channels. The channel capacity corresponds to the number of threads that can simultaneously access the shared resource. Access control, okay. Not more than 3 threads. End process 10. Wait group. Add 10 wait groups to it. What the hell is on? The fuck is that? That's a hell of a zit. God damn. Christ almighty. So what we do is for I is equal to 0, such that I is less than n processes an I. So repeat this 10 times. We're going to call a go routine with whatever function we do. Func ID. Oh no, that's just a anonymous function. We have some ID ints that we pass through here. We have semaphore, which we created as a buffer channel, true acquired slot. Using resource, what's this? So this is using a resource, and then we have time sleep to simulate that it's doing work or something. Release. We then read from the semaphore. We read to it, and then we read from it, and then we say done. Okay. Access control. Thread process ID is using the resource and simulate the process. This is to illustrate which threads can use it, and then it gives us a bit of a time buffer, so then we can see the times at which threads are using the resource. Acquire a slot and then release. So I guess a buffered channel was where, like, how does read and writing from a buffered channel work? So we've got a channel here. Let's say it's like the example, and we've got 3 read writes, I guess, to it. 3 threads. I could just read about a buffered channel. Golang, yeah. Channels can be buffered. Provide the buffered length as the second argument to make it initialize a buffer channel. Sends to a buffer channel only when the buffer is full. Sends to a buffer channel block only when the buffer is full. Receives only when the buffer is empty. Receives block when the buffer is empty. What happens if we run this? 1, 2. So we create a buffered channel. We read to it 1 and 2, and then we print from it 1 and 2. What if we just don't read to it? Run. Oh, piss off. No, run. Waiting for remote server. Hey, there we go. So I'm trying to read from a channel that's not doing anything. Modify the example to overfill the buffer and see what happens. Okay. Run. Problem at 9 here. All go routines are asleep. Well, what happens if we read from it again? Run. Huh? Reset. Run. 1 and 2. And then we read from it again. All go routines are asleep. Deadlock. Jan sent. What if I do 4 here? What if it's a multiple of 2? How does that affect things? Run. Nope. What's this? Sends to a buffer channel. Block only when the buffer is full. Receives block when the buffer is empty. Modify the example to overfill the buffer to see what happens. Oh, what if I stagger these? We do that. Run. There we go. Okay, I see what's happening now. So a buffer channel would work. Because what I could do is is that sends to a buffered channel, block only when buffer is full, receives block when the buffer is empty. So what happens if I print one and then I send shit to it again? What if I just try and read 1 and then So what happens if we are a buffer channel, we push 2 things to the buffer channel, and then I only read 1, and then I push in another one, and then I try and read the last 2. What happens? 1, 2, 2. Okay, so it works fine. That may not work then. Fuck. That may not work. Because the pairs have to be in order. Have I actually ever run this? See if it works. Fan out function. Yeah, we'll just comment that out for now. Did I ever run this? Max distance. I did run it. Syntax error. Where have I made a boo-boo? Sync? No. Butte. All right, around 4 seconds to solve that shit. Max distance, it's found to be 149. Okay. So I will want to use sync for weight groups. I gotta finish this. So I have to make sure that I'm sending the points in order. I have to make sure that it's not happening where I'm feeding the points as a stream, like one after the other, and then different channels are picking from the stream where they like. It should have to be either you send it as a pair or you You either send it as a pair or you have to read from it twice. I think the easiest approach for this situation is going to be having a struct that has a point pair. We read into the point pair twice, or for each, and then it's going to be like adding to the point pair. Well, I've got the point pair right there in each instance. We're good. Yeah. The distance function, what does it return? It returns float 64. Yeah, so we'll create a type point pair. Pair struct. And it will have P1.3D and P2.3D. Well, I could P1. That's a bit easier. Okay. Point pair. So the input stream is going to be a channel of point pair. That is not how you spell pair, dumbass. Yeah, point distance fan out. Now, unfortunately, this code is not very generic, so I can't just apply it with any other thing. But that's fine. It will have to do. Point pair. Are we going to read a stop channel to it? We probably should. Wait group. I've already got a stop channel going to it. Yeah, input channel. And I actually like doing this for readability. Input stream. Oh, that should be it. Okay. And the output should be a channel of float 64. Now, what are you giving me shit for? Missing return. That's fine. Chan key. Oh, that's the out, right out. Okay. Oh, that's the other big thing, isn't it? It's the distance that's being returned. Hold on. Hold on. All right. I need to think, but I also need to pee, so I'll be back. I went to go grab some coffee. I did unmute it, so you guys heard an alarm. All of the 0 people watching. I'll take a little 15-minute break. I got myself coffee, so I'm not pissing myself constantly. Discord's not what I want to have open. Cursed fucking shit. We shall play a bit of TF2 probably. Oh, magnificent. Wonderful. Find a game. Community server. So we'll do some jump practice. Scheisse. I am 2 hours away from overtaking Sniper as my most played class. Damn. I've played this game for so long. There we go.
Soldier, calling here.
There we go. Ah! There we go. You fucking kidding me? There we go. Shoot, that was close. Damn it. We
have commandeered my point.
I need more slack on my mouse. Oh, fuck me. No! That would have been perfect if I strafed properly. No! There we go. Shite. Why the fuck am I having this issue? I've never had this issue before. There we go. There we go. There we go, mint.
Now that is what I want to see.
Tabernacle. Shite. Okay. Butte. Oh, fuck. I got a lag spike there when I... Shite. Nah. Not enough height. No, not gonna make it. Nope. Not happening. Didn't go far enough. Oh, so close. Nope. Okay. Mint.
We have commandeered my point.
Oh. Oh. Shite. Mint. Scheisse. What the fuck was that? Oh, you fucking bitch. Come on, don't you fucking lag out on me, Jesus. Nope, shite. Fucking lag. Okay, maybe I should get rid of one of these on my screen. What I'm doing is I've got the stream open on OBS and then I'm watching the stream from YouTube. So I've got 3 different video streams showing the same thing. Shite! Oh, beauty! There we go. Much better frame rate now. Shite. No, come on. Shit. No. No, come on. No, okay. Too steep of an angle. Come on. Ah, there we go. That's the sweet spot. Mint. Okay. Shit. Okay. Need a bit more speed to make that jump. Shite. Fuck sakes. Damn it. Fuck. What is my... Yeah, internet's good. Damn it. Was not moving fast enough. Damn it! What the fuck? Oh my god, really? What the fuck? I do have my mic and my camera on properly. Okay, good. Fucking shit. Or I slowed myself down too much on that one. Oh, that's 15 minutes. Unfortunate. Fucking load. How long did that run on before you guys... It keeps going. Okay. Alright, let's try getting back to go. Oh, where is our function here? Beauty. We don't have a return statement yet. We also need to pass the function through it. Transformer stage, private public key, wait groups, filter out stage. Here. Yes. Distance. Oh. How does the distance function work again? How does passing by function work again? Distance func. All right. A B point 3D. Float 3D. Float 64. Oh no. Oh. Oh. So how is this going to go? One of the things I'm thinking of is that I can fan out to find the distance properly. That works well enough. The problem... Input stream... Yeah, we can call distance as a thread easily enough. We can call distance as a go routine easily enough. Like we can fan it out pretty simply. And then we get distance as a float 64 back. But then the problem becomes, okay, we need to compare distance to a previous distance thingamabob. And if the distance that we find is greater than the previous distance, then we put in the new points as the new points that are bigger. So what I could do is comment out this bit, and then I can call point distance fan out. And so that will find the distances, but I'll have a difficult time figuring out which distance is the max distance, and then what those points are. Because once I fed the points to it, the function doesn't put it back out. It doesn't come out with the channel. Oh, I also forgot that we have to pass how many channels we want to happen. fan out, yeah, that's going to be an int. Int fan out, yeah. Out, int. So we'll create output stream. That's actually a really clever way for having, like, what is it now? For holding on to, like, keeping, like, not having the wait group close until everything's done here, not closing the output stream until everything's done. Is creating a thread to handle it. Output stream. That's going to be equal to make, and it's going to be chan float 64. Then var wait group fan out sync dot wait group dot fan out dot add fan out. And then for I create that equal to 0, so long as it's less than fan out, we increment. And then we create an anonymous function within here. Go funk yourself. Defer. Wait group dot fan out dot done. Defer print line. End of a distance call. Where we then read in from our input stream, which is going to give us our pairs. I wonder. I could have a distance value in the point pair struct. And I could pass the struct as a pointer, and then I can modify the distance variable, plug it in there. Could work. Back to water. Oh, I did put 45 minutes on. Okay, good. Oh. Oh, well, I'm just not thinking. I'm sort of zoning out. I'm pretending to think, but I'm not actually thinking. It's kind of a problem. So, you can go to paint. So the way it works is that we have some sort of channel that's a stream. And then we have an array of channels. And then for each one of those channels, we need to create another thread so that we read in from those channels into the output stream, or the proper output stream. Because each of these functions are going to have their own output stream. Those need to be read into a single output stream. I'm just trying to figure out how I should go about this. So, what we were thinking about before. So distance. Distance is the main thing. We want to know the distance between 2 points, and then we want to keep track of those 2 points for which one has the maximum distance. So, what we could do is for every pair, we call a thread on the distance function. So what that means is writing each pair to a channel. Yeah, I could do that. That would be kind of fucky. Not the reading each pair to a channel, but I'm thinking, what if I have a function that is a buffered function, and it reads in 2 points, and then it has to read them out into a point pair object, and then that gets sent off to the fan out filter stage. That'd be kind of fucky, but you know, shit is fucky. That would be hilarious. It would maintain the order of the points, though, I think. How would that work, even? No, for each one we get a point pair. We're already in a points here, so we can create a point pair, send it off to an input channel. Mint. Okay, so I don't have to worry about that. I'm overthinking that just a little bit. So here we got distance fan out. We're fanning out all the pairs, sending them to get a distance function thing done. And then it all needs to come back in, but it's only going to be returning the distance. I need to know the pairs as well so that I can keep track of which pairs are the biggest. So I think that's not actually a bad idea of sending a pointer with the struct so that I can change the distance function. So it basically means we're going to be returning the distance.
for each pair. I kind of don't like that though, because then what the hell is the point of the distance function? If we modify the distance into a pointer struct, then, like, yeah, a pointer to a struct of a point pair, then once the point distance function is done, we don't even have to make a note of its output. We just need to go through every point pair that we have somewhere, which we probably got a hold of, and then we got to compare which one's got the highest distance between the 2 points. Let's keep writing and then see where we end up. So long as we're getting something in from the input stream, 4I is equal to the input stream. Select, if we get something from the stop case, or yeah, if we read in from the stop channel, then we just stop. And if we read in something from I, then what we want to do is if we read something in from I, or I guess default. Is default the proper one to do? Default. What I want to do is run the distance function on the point pair input stream. Yeah. So that's going to be I.P1 and then I.P2. And then we send that to the output function. Output stream, shikaboom. And then we can just have that as a case instead. Case. There we go. Go func. Need the function parentheses at the end. Oh, right. I need to also return the output stream here. What's this? Oh, shite. It needs to be a comma. Sweet. So we also need this function here, this go routine. Yeah, this is after the for loop, I'm pretty sure. Go func, and this is going to have, okay, yeah. Wait group, fan out dot wait. Wait. We're gonna print. No, I want print line. It's not end of all filters, but okay, what's happening here? So for as many times as we want to fan out, let's say it's 5 times, but we've got 20 pairs, say. For 5 times, we're going to call 5 different threads. How do I keep this going? So the one thing I'm worried about here is if we have 5 parallel streams, but 20 pairs we need to process, we're only calling 5 threads because that's the number of fan outs here. But for I equals input stream. Okay, so long as input stream keeps feeding them shit, it's going to keep processing through it. And only once we get stop, or only once we stop reading in from input stream, that's when we close. Okie dokie. Okay, so we are going to process the 20 pairs. End of distance fan out. Close output stream. Wait group done. And return. Oh, I know what I'm missing here. And return output stream. Wonderful. So this should work. This should create what we need it to create. We're going to only get distance from the output stream, though, which is a problem. Because we also want the pairs. What I could do is just have a thing in the struct where I have distance in here. Distance float 64. And instead of having the output stream be a float 64, it could be a point pair. Boom. And so I'm not reading into, well, output stream now needs to be a point pair. And so what I do is I create a point pair. And it's going to take in I dot P1, I dot P2, P2, and distance function here. And that should work. Magnifique. Yes. Yes. I think I like this. So then when we're calling this, so in the main here, there's a certain way we got to call it. Oh, I shouldn't. Yeah. Oh no, back. Ew. Okay, now let's go back to this. Fuck. So we have the start, stop, channel, the wait groups, wait group.add 3. So we have a fan out of 16. Here we have a random stream. We're just feeding shit into our random stream. And the random stream is going to go to the filter stream, and the filter stream is going to filter out all the random shit from the random stream. Filter fan out, yeah, that's what we were just doing. Filter fan out. Just filter fan out. It only returns... Yeah, it only returns a single channel. So how are we doing any fan out here? Output stream. What? Oh, they're all reading to the same input stream, so I don't got to worry about shit. Okay. This is when they all read to their own output stream. Okay. So I was thinking I got to do a fan in here. I don't have to do a fan in because we're already all writing to the same output stream. Okay. Mint. Okay.
So what happens here is everything reads from the filter stream. Number of keys, key T, key T, range key generator. What is key generator in this case? I don't know. Keys key. Okay, so filter stream reads into key. So we've already done a fan out here. Okay, we've already got a fan out working. We're mint. We're we can start getting going. Oh my god. Christ almighty. Alright, so let's comment out this block. Save to format. Now what I would like to do, not use P. Okay, well, I will use P. So what I want to create is that immediately restricts the thing. Let's first save the result that we get here somewhere. I'll put it in a text file. New text document. Lab 3 part 2 results. That's saved. Okay. So the thing is that this is all, like in this case, what's happening with random stream is we're already having a thread that creates the stream. So what we could do is we could put all of this shit into a thread, like a function that creates a thread and returns what we want. Oh, I need to pee again. Fuck's sakes. I'll be back.
I think I know why I'm peeing so much. I think I am starting to get sick. The fucking day before my goddamn midterm, I'm starting to get sick. Damn it. 'Cause- I kind of don't want to create a thread for all this shit. Guevayo, guevayo. I don't want to have to just create a thread or a go routine like just to feed in numbers because I already have a for loop for that. I have a silly puppy. I don't want to create a go routine just to read to a channel. I might have to. I feel. Because what I'm thinking of here is if I just have this for loop and then I say, let's create like an input channel somewhere here, say, input chan, and it's going to be equal to make, and it's going to be a point 3D chan, or chan point 3D. What I could do is just have input chan, and I read to it, and I make a point 3D or point pair, and that's going to be p, pt, I, and a distance of -1. Undefined PTS, my bad, points. All right, and I guess -0.1 because it's a float. Too many arguments in conversion to point pair. Distant function. It's right there. What do you mean? Point pair. Ah, shite. create a point pair. My bad, I used the wrong brackets. Now what's the problem? Cannot use point pair value of struct type point pair as 3D value and send. Ah, shite. Sorry, I meant to put this as a point pair. So what I could do is just read to point pair. The problem is that every time I read to point pair, I'm stuck at this line until something reads from it. So that means I need to then create a Go thread to read from this channel. The problem with that is that I can't read to the channel. Or like... Like that it means I have to declare the point distance fan out function somewhere, right? I have to call it somewhere. It needs to be after input make chan, right? I guess I could call it after here. I could like I have to find the input channel here. I could just say output channel. Do I already have an output stream? Where do I have output stream to find? It's up here. Output chan. And I'll make that equal to, what have we got now? Point distance fan out. I need a weight group. So I'll create one of those real quick. Distance, my point variable, 3D, weight group, var weight group. Do I already have weight group defined up here somewhere? I'm not using a weight group. Mint. Weight group sync dot weight group. I'll add to weight group dot one because we're only going to be having one thing going here, which is going to be this thread, the weight, the point distance chan, whatever thingamabob. Yeah, because we take in a weight group here. So that's going to be weight group. We need a stop channel. Nah. Stop is going to be equal to make. It's going to be chan bool. Right, I need to pass the pointer. Stop. Input stream. Input channel. Fan out, we'll call it 5 times. Distance func. So yeah, I just passed the distance function. Oh, distance 3D. Yeah, that should be it because I'm already going to be passing that. And yeah, that should be it. Oh, what's causing me grief now? Output chan. Declared not used. Output chan. Oh, that's fine. Okay. So now I have threads that are waiting to read from input chan. Will this work? We shall see. So the idea is... we make an input channel for point distance fan out to read from. We also have a stop channel. We then say we create an output channel, and that creates point distance fan out. And this essentially says we got all this shit. We make an output stream, a weight group for the fan out, and then we add that many in. So we're going to create 5 threads for that shit. This is create those 5 threads, and then just for I is equal to range input stream. Just all read in from the input stream, essentially. So long as you don't get the stop case, just keep going. I think that's what that means. Like input stream for I is equal to that. Like we're not doing a Boolean here, right? We're not reading nil from it.
I guess we could read nail from it. How do channels work again? Concurrent programming. Oh, there's a nifty table here. Yes, a closed channel immediately returns 0 or false, or there's a panic. Closed channel. Oh, it's still open. Blocks until value is sent. Okay, blocks until channel is red. Yes. So the channel isn't closed, so we don't got to worry about that. The channel is open. Oh, that's my 45-minute timer. I'll keep going because I'm on a bit of a roll here. I'm in the midst of thought. Yeah. We're going to be creating 5 threads, and they're just going to keep reading. Input stream is going to be open. We don't have to worry about that. We haven't closed it yet. Keep reading to input chan. It's open. As soon as it's as a pair is sent here, it's going to be read by one of our threads. It's then going to shit that to the output stream. And so for each thing coming through the output stream, for pair is equal to range output stream. Is it output channel that I've got here? Yeah, output chan. What I want to do is call this essentially output chan if distance is less than i.distance or pair.distance. Then we create distance is equal to pair.distance. Distance is going to be equal to pair.p1 and pair.p2. No, pair.p1 and pair.p2. P2. Excellent. And then we we close the stop channel. We do wait group dot wait. I believe that's how we're supposed to be doing it. Concurrent programming. No, you bastard. Oh, it sent me right to the fucking start again. God damn it. Fan out. Yeah, when you're reading from it. Yeah, you close the stop channels and then you wait until all of them are closed. We only got one thread going here. Output chan. That's why I should be doing it as a function, because the function should handle all things related to the channel. Okay. Okay. That's right. I forgot about that. Whenever you're making a channel, you want all things related to that channel encapsulated within a function, because that function's going to take care of closing that channel and the scope for what that channel should be open for. Okay, so I do need to create a function for the... all right. Func create pairs. So that's going to have to take in a wait group pointer. Wait group, sync wait group. It's going to have to take in the stop channel. It will have to take in the pair. I think it just needs to take in the point pairs, essentially. The points function there, yeah, the points array. That's going to be 0.3D array. Does it go at the start? It does go at the start, dummy. Anything else that I need to send it through? Typically there's the fan out number, and then there's distance, which is the function that's returning. I think at that point I'm set to go. I just need to return the channel, which is, what's the input channel I've got here? I think that's a point pair input stream. Yeah, point pair. Chan point pair. And so at the start we defer weight group fan out. Yes, yes, yes. I don't know. Okay. Do I defer weight group? How? For just pipeline strategy, pipeline pattern. This is it. Okay. Filter stage. Go func defer weight group dot done. Okay. So it's okay. Okay, so this all waits till the fan group is done. So that's why that's there. Okay. So yeah, that's done by the threads, the deferring of the weight group. Okay. So output pair stream is going to be equal to make dot chan point pair. Boom. And then we go create an anonymous function, go func yourself, defer weight group dot done, and defer the closure of the output stream. Now you can see why I think I'm starting to be sick. So defer print line. End of pair generator. And so then I need to, in here, I don't have an input stream, so I don't got to worry about that really. This is the filter stream, pipeline pattern. Yeah, there's a generator that he's got here, essentially, controlling the generator. Generating a channel, sending a unique output to a function. We have the weight group, we have the stop channel, and then the function. This is the function for generating shit. I don't care about that. We're just gonna, I don't need to generalize it too much. So yeah, so weight group dot done, close what's the output stream that you're sending. Something for a thing, an infinite loop. I don't need an infinite loop. All I need is to create it for each pair. Do I need an infinite loop here? I really hope I don't. Oh, I'm worried about that now. Generating a channel, sending the output of a function. Generator thread. Monitor mutex generator thread, controlling the generator. Stop, defer, close, stop. Weight group dot add, random is equal to repeat function. Is this repeat function that we've got here? Yeah, repeat function. So this just goes for as long as you want it to go, but I don't actually want that. I want it to only go for as many pairs that we have. So we'll copy in this code. Control C so it formats itself properly. It does not want to format itself properly. Go func. What's this? What's the problem here? All right. Boom. Input chan. Now we're actually reading to output pair stream. And an output in a pair stream. Missing return, right. Return, output pair stream. Top, stop. Okay, Jesus. Yeah, I guess I'm not using the stop thing here. Do I need stop? Stop is typically used if we have a infinite loop. Yeah, send to channel to stop to terminate. I don't need that. Yeah, I only need one thread to do this, to write to the output pair stream. So I guess I don't need the stop channel. I might just keep it in there for shits and giggles, because who knows if I might need to return back to this. But create pairs now. Input channel, and instead of make chan or whatever, and then having a stop, we'll put the stop up here. We'll have a wait group 2, and instead of make, we will have create pairs. Create pairs, wait group, use the @ so that we're sending its address. Wait group, the stop channel, and points. So actually start's going to want to go up here now. This is all redundant now. So I'm going to undo the comments here, because this is the old way of doing it. I'm just going to comment all of that out. So is this going to work properly? We have create pairs, we have a wait group, we have a stop function, we have points. Output stream, we create it. And then we go with this bastard. So essentially this thread goes, and it's going to go, say, for 20 pairs. Let's say that's how many we have. And it's going to defer wait group. It's going to close the closing of the output pair stream, and it's going to defer printing end of pair generator. And for 20 things, it's going to read to the output stream. So one thing I'm worried about is premature closure of the output stream. That's not going to happen because we are reading to the output pair stream, and we don't move past this line until something reads from the output pair stream. So yeah, that's only going to happen when output chan is... the input channel here is read by points distance fan out. So we're going to have to go through each thing, like each pair, before this closes. But this will close properly, and it doesn't need stop to stop because it's not being run infinitely. I can just keep it there as an artifact in case I need it. I will do that just in case, smiley face. And then what's going to happen is we're going to have this. We're going to create 5 threads, say, and it's going to defer the... Do this 5 times, create a thread, defer its wait group until we're done here. End, not ent. Defer the printing of the end of the distance call there, and just keep reading from the input stream. So long as it's open, just keep reading from it, and then write to the output stream here. And so that should keep working. We've also got a stop thing here. I don't know if we need stop, but it's there, you know. But this is also going to keep going. This is going to wait on this thread until all the fan out groups are done. It's then going to it's then going to proclaim the end of the fan out. It's going to close our output stream, and then this one's going to call done. And so we will be waiting here until shit's finished. So of course we're not going, for each fan out thread, it's reading to an output stream. And so we're not going to move past this line until we're back in here. This basically says, so long as the output channel is open, I want you to read from it if there's something there, and check it with our distance thing. And if it's distance is less than the distance that comes in here, you update everything from that pair. So let's see if this will work or if it's just going to immediately shit the bed. Number of that's previous one. It's already longer than the previous solution. I think I have an infinite loop somewhere. That's unfortunate. Or do I have an infinite loop? You just keep doing what you're doing. We'll see if that finishes at any point. Let's go at line by line. So lab 3 part 2 main section. We're going to read in the points. We already know that works. We have distance, max points, good. And then we're going to create a weight group. I have 3 things going to the weight group. There should only be 2. That may have been the problem. We're waiting because nothing's getting closed at the moment. Yeah, that may have been the problem. I'm going to run 5. 1, 2, 3, 4. Okay, it's still longer. We still have an infinite loop somewhere. So we've created a weight group. We've added 2 to it. We have 2 channels that are reliant on the weight group. So we're not closing these threads, or we're waiting on the system until these threads are closed. So what's happening here? We have the start. We make our stop channel. We create our input channel. We go to create pairs. Create pairs is just going to take in the points function, the points array. And then it's going to create a thread where it reads to an output stream for every point that it generates. So, yeah. Read for every point that we have, like every point pair. For every point pair, it's going to create a point pair where it passes the distance and shit like that. And then it's going to pass it to the output pair stream. The output pair stream is then created here, where it's known as input chan, or the pair channel. And then we want to pass that to point distance fan out. That's where we have the weight group. That's where we have stop, input chan, all that good shit. Maybe also have this open on the side here just to better illustrate it. So what we're creating is we have one channel here. That's not the shape, damn it. Rectangle. We have one channel here, and then we have 20 things being written to it. We have 20 things going into this channel, or that should be going to this channel. This channel is then read to 5 different channels. 1, 2, 3, 4, 5. And they all read out to the same output channel. So, yeah, there, 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 and there. They should all read back in here. So when it generates one pair, when one pair is generated, it goes into the channel. If the channel is immediately picked up by one of the fan out channels, it goes here, say. It then processes it, and it's going to wait until its output channel. No. Yeah. Yeah, what? Okay. Fuck, okay. These are not channels, these are threads. I probably have a conceptual problem here. What is happening here? Create pairs. I'm gonna delete this because it's all redundant now. So this is only gonna run about 20 times. And it's a single thread. A single thread runs about 20 times, and it feeds to the output pair stream. We then get to here. This is going to read from that output pair stream, and then we're going to create about 5 threads, but they're all reading to the same input stream. Yes, okay. Well, it's all reading. Yeah, it's all reading from the same output stream, and they all read to the same output stream. I say output stream way too easy. It's because it changes, right? The output stream of create pairs is the input stream of point distance. Why is language so fucking hard? Is it still going? It's still going. Okay. We'll let it do its thing. We'll have it figure itself out. Yeah, that's the function here. So we're all reading from the same input. And what happens is, well, yeah, we were going line by line. Let's do line by line again with input chan. I could have just made us like the functions here that control the channels. I could just be a fucking moron and not realize something important. So we create the output pair stream. We then create a thread. Create a separate thread. This thread goes through a loop 20 times. 20 times it should read to the output pair stream. So we defer the wait group being done. That's being passed here. This is this wait group right here. We defer the closure of our output pair stream, and we defer this print statement until we go through the whole of the points array. We then go through the points array again for each index that is incremented from above that, and we throw in each pair. We create a point pair, and we throw it to the output stream, and then we return the output stream. The output stream's already going to be returned. This is our thread here. So even though this function has returned its thing, this thread keeps going. But this thread is not going to complete until the output pair stream has been read from 20 times. We go to point distance fan out. We take in the output stream of create pairs, and that's our input stream. We create our own output stream, that is a point pair. We create a wait group for the fan out section, and we add to that wait group as many fan outs as we are looking for. Maybe we're getting stuck here. Maybe we are not closing fan out enough times. Maybe this is supposed to go in here, because what could be happening is that we're only closing the wait group fan out once, and so the wait group never actually is done. Wait, no, for each one we're doing it up there. Okay, never mind. Yeah, we defer, we create a wait group of size 5 in this instance. And we defer calling the done function until this is completed. This function is done. So what happens in this function? We tell it to always read from input stream so long as it's open, and it stays open until it's been read from 20 times, as we know from create pairs. And what we do is we then read from it so we can call our point pair function, and then we write that to our output stream. But once this is all done, we then call wait group.done. Or yeah, the fan out wait group.done. And there's a separate thread that stops the closure of the output stream until all those fan out wait groups are done. And we haven't reached that yet because we haven't seen this. We then close our output stream, and then we call done for this thread overall, which is important for this wait group, this line right here. But then again, we are also reading from that output here in the main file. So it's basically saying so long as the output channel is open, we're going to compare all this shit. Boom shakalaka. So, yeah, no, I'm still confused where exactly we're having a problem. That's going to keep going. So I think we'll just have to jump into debug mode. See where the hell we're having our issues. Line by line. Oh, shite. Terminal. Ports. Problem. Number of over 2. I need to write to my fucking terminal. I will just comment out all of lab 1 at the moment. Lab 3 part 1. And we will just... Okay. All right, so we should be fine to run this now. Input channel create pairs. We'll jump into that. Step into create pairs. So output pair stream, good. There's go func. Return output stream. So now we've got that thread going. My lord, create pairs. Create pairs func1. What's this one? Create pairs. So this is the function now that we're doing here. I think that's our anonymous function at the moment. And that's done. Okay. We're in channel.go. And we wait, I guess. What's happening here? We are now back in here. We are trying to write. Yeah, we're in func1, so I was right. That is our anonymous function. And so we are consistently writing to output stream. Problems. Okay, let's not new ports. No. Debug console. If I'm constantly writing to the output pair stream, that means it should be being read from at the moment by our thingamabob. This should be being constantly read to or read from. So main create pairs. We should have, it should be being read to at the moment. So we should have main. Yep, there we go. There's our 5 fan out functions right now. They're all currently reading from this at the moment. So main distance fan out func 1, yeah. And then main distance fan out func 1. Main distance fan out func 1. Okay, so it is being read from at the moment. Oh. Did I make a fucky wucky somewhere? Wait, did that happen after 5 cycles through the... 5 cycles through the, what is it now? The loop here. Turn. Input chan. Output chan. Okay. So create pairs. Our create pairs function still going here. It's going strong. So if we can look at that. Okay, so that's going at the moment. It's waiting to read to output pair stream. So let's go back to our main here. And we'll jump into one of these. Step into. Boom. Create our output stream, fan out, add. And then, so we've now created distance fan out. We should have created 5 now, or that's just the 1. That's 1 thread. We still got to create the other ones. There's the second one. There is the third one. Oh, have we got a problem? Step over. Oh, we're in one of these now. Oopsies. That's not what I meant to do. Let's go back to main. Or not main. We are looking for main.point distance, but not func1. That's main create pairs func1. These are all the threads that we've created. 1, 2. Oh, fuck. How do I get out of here? Okay. So let's just look inside one of the threads, I guess, in the fan out. So we're going to read from the input stream, in case stop, in case that. And so I guess we're reading from there. We have I. Yeah, we have successfully read from the output stream. We'll just keep doing it. Let's see what's happening here. So that was second. We're on our 3rd loop. Okay, so on our 3rd loop, it seems that we're still reading. 4th loop. What's happening here? It keeps going back to the select statement a few times and reading from the output stream. Does I change each time? Is it waiting to be read from? Because it doesn't look like it changes each time we have our select thing. Is it just, does it keep running essentially until it figures out, oh, one of these is open? Like output stream. Okay, so we'll just keep going. I want to step out of this though. So I'll just, I don't know whether to do step out or this and what that's going to tell me. Maybe we reach there. I don't know. Continue. Yeah, that's the thing now. I don't know where the fuck we're waiting on. So I'm going to stop. I'm going to go back to the main function here because I think it may be a problem with reading from in here, reading from the output channel. So we'll skip over that. We'll skip over that. Beauty. So we are getting a pair from here, and that's a distance. Excellent. So our distance has changed, and so has our max points. Read from all that. Good. Distance has changed, and so has our max points. Point pair. It's not if statement is not true. Here we do have a true statement. Those are updated. Not larger, not larger. I guess I could just keep going for this point. I think where we might be getting hung up is the close statement. Let's see. Hold on, I'll try that again. Okay, those channels are all being done. And then if I hit I'm not interested in going through all of these. Like, what's the size of points? Length. Yeah, that's a fucking lot of points here. I can't fucking... Okay, Shit. That is a lot of points, motherfucker. Yeah, I can't do that. Let's go to print line. Let's create a print line statement just so we have a function that can be, we are reaching line 95. The big question is, are we reaching line 95? We are not. We just keep reading from output chan. Output chan just keeps fucking going. Stop. I'm pretty sure that's what that does. Yeah, let's make a quick channel of range channel Golang, yeah. Yeah, the sender can close a channel to indicate that no more values will be sent. Receivers can test whether a channel has been closed by assigning a second parameter to receive the expression after. Okay is false if there are no more values to receive and the channel is closed. For loop I is equal to C range C receives values from the channel repeatedly until it is closed. Okay, so the problem here is that output chan is never being closed. So that's a problem with point distance here. Output chan. Output stream close. Okay. So why is output stream never closing? There's a go func here and wait group. Okay, I need to pee, so hold on. I was doom scrolling on my phone. I saw a dog being a little piece of shit on an Instagram reel. And I said, "You little fucker," out loud, and then my dog came running. So make of that what you will. All right, so the problem here is that output stream is never being closed. We just keep reading from it continuously forever, which is no good. I think what I'm going to do is I'm going to, for testing purposes, create just a slice of points and pass that through so that we can actually reach to the end of it and ask ourselves what the fuck's going on here. Okay, that's all being done. Points. I want a point slice, and that's what I'm going to be sending here. Slice is going to be equal to points, but I only want up till about 20. Nah, let's make it 10. Oh, sorry. Boom. And then we'll pass point slice instead. Okay. Let's debug this bitch. Point slice. Length of only 10. Mint. Yeah, just keep going. Through. Oh wait, that's still quite a few combinations. We are reaching line. Okay. So we've successfully reached the end. Close, wait. Is it just that my solution is atrociously slow? What the fuck? How is my concurrent solution so much slower? What the hell? Let's go to 20. We'll re-fucking do it. Hold on. Yeah, slice is 20. Re-fucking do it. Slice, boom. And so we're just going to... Yeah, it reaches the end. End of pair generator, end of distance call. 5 of those end of distance fan out. Why so slow? What the fuck? What the actual fuck? Well, it finished! It's not a fuck. No. It's not an infinite loop. My concurrent solution just sucks so fucking bad that I have turned what was a 4-second non-concurrent single-threaded solution into a 14-minute concurrent solution. No! It works fine. It works fine. It's just slow as fuck. Okay. Oh, no. No. 14 fucking minutes. No. Oh, no. Okay, so I think I need to increase the fan out. No, it's literally that a fan out of 5 increases the overhead of the threads to such a degree that it just completely nullifies any sort of gains from a fucking... It not nullifies any sort of gains from a concurrent solution. It actively harms and the gains from a concurrent solution. Fuck me. Oh, no. Oh, that's horrific. That is horrific. Oh, fuck. No.
We are... Why is it being so atrociously slow? So, yeah, let's keep point slices up here for a moment. Why is it so slow? What is the thing here? It needs input channel. Oh, I had 5 here. Let's go with 10. Or better yet, let's go with 50. And let's say this is a slice of 1,000. Why is my concurrent solution so fucking slow? Okay. Oh no. 1, 2. Okay, that took about 2 seconds. And the max distance that it finds is that. What was the one that I was finding before? The max distance. It was 147. Okay. Ow. Ow. Why does my head hurt? My head hurts a lot. That is so atrociously unfortunate. Oh, I'm angry. I'm angry. Let me just figure out for a quick second how big of the actual slices we're working with are again. Points. Yeah, points has a length of 63,000. 63,000. That's quite a bit. Let's see. Let's do half of that. Let's do half of that and see how long it takes to solve it. We've got 50 threads going here. Yeah, point slice. Or we'll just call points. No, we'll keep, yeah, points. We'll reassign it to like half its. Why are you giving me that fucking shit? No new variables on the left side. Okay, I could just do boom. And instead we'll make it like 30,000. Reload. So it's a length of 30,000. And we'll just see if 50 data parallel threads solve it in an appropriate amount of time. 1, 2, 3. I'll just put on a fucking... Where the fuck's my phone? Did I leave it in the bathroom? What are you doing? Oh, you silly boy. Clock. Stopwatch. We are still waiting on it to be done, Cap. What if I do like 100 or like 500 concurrent threads? Yeah, let's give her a whirl. Start.
All right. I'm going to stop that. I'm going to concatenate this to 1,000, and we'll have 500 threads. 500. No. Instead, I'm just going to run it from here so that I can get the time. Because at this point, I know that it's just my concurrent solution sucks ass, and it's not much more than that. And we'll do, I don't know, 500, we'll give it a shot. We'll see if it works. Execution time. Beep. That was actually pretty fast. Well, that was for 1,000. What happened? I don't know what it is if it's not 1,000. Like if it's in the non-current thing, because I haven't tested how long it takes to do it with 1,000. All right. I'm going to get rid of these print functions here. In the function. New. Don't want it. Get out of here. You're just cluttering my shit. Now we'll make this 2,000 or 10,000. It's still running. Why is it so slow? Why is it so fucking slow? Can I do 5,000 in a meaningful amount of time? Oh, I did not save that shite. Control Z. Boom. There we go. Took about 20 seconds to complete, which is still atrociously long. Like, it was taking me 4 seconds with the single-threaded solution. No. Yeah, 4 seconds. What the hell? Yeah, what the hell? What was lab? Read points, that's fine. Literally just go through each fucking point. Just loop through each individual point. I don't get it. Well, that was 20 seconds. Let's see if I boost that up to 1,000, if that has any meaningful impact. Well, let's, instead of doing that, let's do it for 1,000 seconds, and we'll keep it to 500 threads. Or better yet, we'll take it to 50, so I can increase it and see what effect it has. All right, took about 1 second with 50 channels. If 100, well, let's see, run it again. Yep, about a second. Reliably a second. Okay. So if I updo this to 100, does that meaningfully increase the time? No, it's actually kind of more. Yeah. It's 1.05, 1.07, 1.08, 1.05, averaging 1.06, and it's 1.01, 1.8, 1.92. Okay, so it went down a little bit. What if I do 200? Yeah. Oh. We are seeing it increase in speed. Now 500. Yeah. That does make it go faster. It took 4 seconds with the non-concurrent approach. So, like, I'm thinking, if we just have this at 1, it should be close to the non-concurrent approach. We just have the overhead for the threads is about it. So what's happening here, input chain, create pairs. Yeah, we create a thread that runs 20 times to create all the pairs. And then for this, we essentially just create one thread at this point. And all it does is the same thing as this point. It calls the distance function. And then, or it processes the distance function. And then it's read. So what happens with this? Go run. Yeah, one thread is remarkably fast. And then, let's just say I get rid of points here, like this bit, and we run the whole thing. Let's see if it's also just runs at 1 second. Or 4 seconds. Yeah, it seems to be going a bit slower. What the hell's happening? Why is it so much slower than the single-threaded solution? That's the one thing that I don't get. Ugh. Man. Yeah, so I'm gonna do this. Kill that. We'll do an if statement here. Wait, group.add. No, this will be before. Quick if statement. Var single thread or concurrent is equal to false. And I will do if not concurrent. Then we'll do the solution. And else we do the solution. Cleared not use start. Yeah. So start's gonna have to go up here. X. So this is basically the old solution for each thing in your thingamabob. Start, end, and then just make some more white space in here so it's more easy to read. yeah, basically create your points, set the distance, have the output thing start. So if you have a non-current solution, you're just going to go through every combination of points, and then you're going to call the distance 3D function. And if the distance that you get from this function is less than distance, then you calculate that as your distance, and then you reset the points, like the pair of points that have the maximum distance between them. And that's literally it for the single-threaded solution. Very simple and straightforward. So it should be the one running here because I've got concurrent set to false. Yeah, it took about 4 seconds to complete. Four seconds. All right. So wait group, add, have a stop channel. These two things here, which is a thread for creating pairs. Creating pairs writes it to an output stream, which is the input channel. And it essentially does the same thing as before. It basically just writes to the output stream, like for every pair. For every pair, we write to the output stream. It's essentially the same as what's being done with this for loop. We then send it to point distance fan out. So where is most of the slow shit coming from? You'd think from here it might be the distance function, but we know that's not the case. The distance function can be computed relatively quickly. It's just the number of shit that we need to call for. I think that might be the biggest problem here. That might be why my solution's so slow. I've got the fan out doing the wrong thing. Where it's slow is not the distance 3D function, finding the difference between 2 points. It's actually just calling all of those pairs. That's the thing that's taking up so much time, because it's 63,000. And then it's all the different pairs within there, which I think is like a factorial or some shit like that. Factorial? I don't know. Well, let's say here, for index, so let's say index is n, and then we're going for n times n minus 1. Or yeah, so we have index here, like let's say we have 10 points. And then for index 10, we're running it 9 times. And then for index 9, we're running it 8 times. What is that then? Oh. So it's not this part that is the time-consuming part. It's this part. It's finding every single fucking pair. Trying to think how you break this up now. So I think that might be why this shit's still so fucking slow. It's because I'm adding up so much overhead on what is easily one of the fastest parts of the code. So I'm creating 500 threads to do something that's trivial, which is compute the distance function. Distance, like, yeah, it's taking a square root of two numbers, but that is trivial compared to the number of pairs we have to find and do this call on. That's not being truncated, or that task is not being split between threads. So that's why this is taking so much longer, because the actual intensive part of finding all of those pairs is not being split up between multiple threads. So what I'm thinking here is, in this part, we have index over points. And it basically says go over the entire index. And when you're at index, like for index, at index, increment to the next number, and for I, and then do this for all numbers above it. For all numbers above it to find all pairs. Yeah. What I'm thinking of is splitting up the indexes and having multiple threads finding the pairs. So let's say we have 20 entries or something, 20 indexes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 can't be devised by as many as I want to, can it? Yeah. Yeah, let's go with like 22 or 24. I think 24 can be devised by more numbers. So basically, the main idea here is, how do I move around? What the fuck is this? No, I don't. Boom. The idea is, let's break up this index into so many smaller chunks, right? So you have 24. 24 is easily divisible by 4. So let's divide this up into chunks of 4, right? How did I fuck that one up? 20. Yeah, because 20 is... I forgot 21, 20. I can't count. What do you mean I can't count? 21, 22, 23, and 24. Here we go. And basically, we split up that first part of the for loop because we can't really split up the second part. At least maybe we could. I don't know. So each of these goes to a thread, and this calls for each number above where we're at. So this only handles numbers 1 through 4, and then it finds all the pairs of 1 through 4 with everything else. Like, so we find the pair of 1 with 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And then for here, same thing. It handles only the indexes 5 through 8, and it finds all the pairs of 5 with 6, 7, 8, 9, 10, 11, 12. And so the smallest thread is going to be the one doing this work, because it only finds the pairs of 21 with 22, 23, and 24. Yeah, I don't know how to split up that second part to be any less, is the problem. This is at least a start, so we could try that. Yeah, it's just atrociously slow because we are calling 500 threads to do the most trivial part of the work, when the hardest work, where the work is the thing I actually need to split across multiple threads, is the finding pairs aspect. So I'm gonna completely rework this. I won't need a generator, I don't think, anymore. So we'll recreate the point distance fan out. I don't think I'll need create pairs anymore. So I'll just cut this and move it to the end here where I don't have to look at it. And then point distance fan out. We'll keep the name, but I think I'll gut most of this code. I'll just comment it out for now, essentially. Missing return statement, that's fine. So okay. Need to take essentially this, copy it in here. Points, that's fine. So I need to pass the points. Christ. Okay, my brain can't think right now, so I'm gonna close the stream and take a little break, and we'll perhaps come back to this later in the day. Because I'm trying to think and it's just not happening. Alright, see ya.